Welcome to our exploration of robotics with the Raspberry Pi. I'm Kevin.
And I'm Kyle, and today we'll be showing you how to build your own Wi-Fi controlled wireless Raspberry Pi robot.
The Raspberry Pi is a versatile single-board computer that can be used for a variety of things. This is due to the wide variety of hardware and connectivity. In this project, we'll be utilizing the 5 GHz Wi-Fi and the GPIO pins with the Raspberry Pi camera accessory.
In our robot, the Raspberry Pi will control the motors, receive input from our computer, and live stream camera feed to a local web server. The following materials you will need for this project is a laser cut wooden piece to resemble a car, your 2 motors, your 2 batteries, your jumper cables, your motor driver, your ball bearing with a ball socket, your battery pack, and your screws.
Additionally, you'll need a Raspberry Pi camera, a Raspberry Pi 3 or 4, the appropriate cable to power it, and a power bank. So, let's start building the car. Just a note beforehand, we've hot glued the motors with the wheels onto our frame. So let's begin. This is the top part of the car, this is the bottom. We'll have to take 2 male to female hex standoffs, which are 6 millimeters tall. We'll put it from the top, flip it to the bottom, and screw a second standoff. And do it for the second side too. Now we'll be installing the ball bearing.
So as you can see, at the bottom of the car, we will align ball bearing, and we'll take our nut, and we're gonna, at first we're gonna do it by hand, and then after you're gonna need a screwdriver. So this is how it should look. So something like that.
Next, what we're gonna do is we're gonna add the motor controller. All we're gonna have to do is line up the 2 holes on the controller and the 2 holes over here on our hex standoffs. We're gonna end up using 2 M2 6mm screws, and we're gonna just screw them in to these holes. Now we'll do the same thing for the other side. The finished product should look something like this. Now we'll move on to the second part, which will be connecting the power cables on the motors to the motor controller. So for this part it doesn't really matter, but you'll plug in the positive and the negative into the 2 holes over here for the wire connectors. Shown here, 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 and here. We'll start with the negative at the front. Next, we'll connect the positive. The finished product should look something like this, where the 2 motor cables are going through the bottom. They're being fed through and connected to their appropriate part in the motor driver. Next, we'll be adding the battery pack onto the bottom of the car.
So for our first step for this is to open up the battery pack and add your batteries. You want to make sure that you're connecting your batteries in the right sequence. So you want to make sure that negative goes to the spring on both sides, so it should be opposite. And then you want to close it back up. So you're gonna take your soft Velcro first. Just any length doesn't really matter. Now you want to take your rough Velcro and you want to just chop it to the appropriate length. Now you're gonna flick it on, just like that. And you're gonna pass it through your two loops, just like so. And now you got your battery pack stuck to the back of your car, so something like that. And then you're gonna pass your positive and your negative through the holes. And then you're gonna catch them on the other side. Our next step is gonna be to wire. So as you can see, we have our 12 volts here, our ground in the middle, and our 5 volts over here. So black is our ground cable, and the battery we're using today is a 12 volt. So what we're gonna do is we're gonna first undo all three of these, and the two that we're gonna use are the ones to the left and the ones in the middle. So the one in the middle is for our black cable, and the one to the left is for our 12 volt. So what we're gonna do is we're gonna first undo them. Now that the two we're using are undone, we're gonna plug them in. Now both of our wires are secured properly and tightly, and they're all tight. So now our motor driver is successfully fired.
Next, we'll start by adding our power bank. We already have Velcro pre-installed on it. You could install it yourself, and we'll continue from there. Once you have your Velcro on your battery pack, we'll cut the opposite side of Velcro accordingly and connect it to the back of our RC car chassis and body. Now that we have our Velcro on the car, we'll connect our battery pack and the Velcro. Now we have our power bank on. We'll have to connect our Raspberry Pi and also connect it to it with Velcro. We're going to get one side of the Velcro, cut it accordingly, and stick it on the bottom. Take note that on your Raspberry Pi, you'll need to have a 32 or 64-bit operating system of Raspbian pre-installed on an SD card. Next, you want to install the Velcro on the other side of the car. Now that you have your Raspberry Pi and power bank onto your car, we can start wiring.
Now for our next process for completing this car is to connect our Raspberry Pi to our motor driver. So the first step is going to be connecting pin 1 on the motor driver to pin 29 on your Raspberry Pi. Then we're going to connect pin 2 to pin 31 on the Pi, and then pin 3 gets connected to pin 33, and finally pin number 4 on your driver is connected to pin 32 on the Pi. So our first pin that we're going to do is our pin 32. So that's going to be on the outside, and we're going to bring that to pin 4 on your driver. And now our next one is going to be our blue, so that's going to be pin 31, pin 3, and then our black one is going to be to the left of that, right of that, and that's going to be connected on the outside to pin 4, and then finally our green wire. And now we're gonna plug it into our only port left. So now we're gonna ground and put our power into our Raspberry Pi and our motor driver. So we're gonna connect first our ground cable, which is gonna be our green cable for this example. And we're gonna put it to our third pin right there. And we're gonna, over here on our motor driver, we have our 12 volt ground and then 5 volt. So we wanna make sure we're putting our ground into our ground and our 5 volt into our 5 volt. The common mistake I see with most students is they put their 5 volt into the 12 volt, so you wanna make sure you're careful of that. So now that we have our ground in, we're gonna put in our 5 volt. We're gonna unscrew our 5 volt and screw it in. Yeah, make sure it's tight. And now we have our ground and our 5 volt connected. Now we're gonna start to wire our Pi camera. So first, it's important to remember when wiring our Pi camera is that our blue tab should always be facing our Ethernet port. So the 2 USB ports and our Ethernet port. So the first step to this is a little bit tricky, but you want to either use your fingers or you want to use a flathead screwdriver to try to pry out the black tab. But it comes out really easy, so you don't want to use too much force. And then we're gonna put it through our wires and we're gonna plug it in with the blue facing the Ethernet once again. And we're gonna plug it in and then we're gonna squeeze it down. So now your black tab should be down and you wanna give your Pi camera a little tug, and if it's not moving, it's good. So now you're gonna mount your Pi camera anywhere you'd like on your bot, but we chose to do it on the heatsink of our driver, but you can choose to put it anywhere you'd like. So we just took some tape that we had remaining and we just taped it right onto our bot.
Hi, I'm Owen and I'll be doing the coding part of this project with you guys today. So before we can do any coding, we're going to need to set up our Raspberry Pi SD card. So first, to do this, we're going to go to Raspberry Pi's website and download the Raspberry Pi Imager. And while we're downloading things on our computer, you will also need Real VNC Viewer, so download it from this site here, and PuTTY, download it right here. So after you've downloaded and installed all of these things, the first one that we're going to need is our Raspberry Pi Imager. So under the operating system, we're going to select Raspberry Pi OS 64-bit. And then we're going to go to the settings. In the settings, you need to check off set hostname, enable SSH, set username and password, and configure wireless LAN. You can set the hostname to whatever you want, just make sure you remember it. The username and password can be whatever you want, also make sure you remember them because we'll need them later. And configuring the wireless LAN is connecting the Raspberry Pi to your Wi-Fi. So the SSID is the name of your Wi-Fi, and the password is the password of your Wi-Fi, so put those in. Once you've configured the settings, you're going to choose what to write your operating system to. So plug your SD card into your computer and you'll see it show up here. It'll show up as an SD card with your storage space on it. Left click it and then you're going to click write. Once your SD card is done writing, take it out of your computer, put it into your Raspberry Pi, and turn your Raspberry Pi on. After you've given your Raspberry Pi a few minutes to boot, we're going to open PuTTY and type in our host name. So in my case, it is Raspberry Pi 4, and you're going to hit enter. If this is your first time connecting to it, you'll see a pop-up come up here. There will be some buttons down here that says connect once and accept. Just hit accept or connect once so you can connect to your Raspberry Pi. Now here we're going to put in our username, mine's MCCuser1, and our password. Now if you can't see your password, don't worry, you're not supposed to be able to. Hit enter. And you should see this. Now, we want to find out the IP of our Raspberry Pi so we can connect to it through VNC. To do this, we're going to do host name -i and hit enter, and this is our IP. Now, before we can connect to VNC Viewer, on the Raspberry Pi, we will have to set up our VNC Viewer. So if you don't know how to do that, go find a tutorial on how to do that now and then come back to this video. So now that we have our IP, we're going to open up VNC Viewer and type it in. I don't believe copy and paste works. So once we've typed in our IP, hit enter, and this will come up. You're going to put in your username and password from before. You can hit remember password if you want. Once we are in our Raspberry Pi, we can now start coding it. So to do the coding, we are going to use the program called Donny that comes preloaded on the Raspberry Pi, so go ahead and open that up. Okay, now here is the code that we're going to be using. It is linked in the description. So I'm going to go over the code quickly. So the first part of our code is importing all of our libraries. The main ones that we are using here is PiCamera 2, which tells the Raspberry Pi how to use the Pi camera, and Turtle, which allows us to use our keyboard to control the Raspberry Pi. These are our variables that basically tell the Raspberry Pi what pins our motors are connected to. So sending power to what pin will do what. So if we turn on pin 31, then the left wheel will move back. And these you can set yourself. If you didn't use the same pins as us, just trial and error until you get the right pins for the right actions. So now these are our functions that we're going to be using to drive the robot. So this first one basically just sets up our robot, telling Turtle to initiate, turning off warnings, setting the mode of the GPIO pins, and telling the Raspberry Pi all of our GPIO pins are outputs, not inputs. So all of our functions here have to do with the robot moving, and they're pretty simple. So the first one prints that the robot is moving backwards, and it tells the left wheel to move back and the right wheel to move back. As you can see, the true meaning it's going to be doing that. And that is the same for the rest of our defines, like turn left makes the right wheel move forward, and also prints turning left, and the right wheel, when it moves forward, will turn the robot left. And then our stop function is just turning all of the motors off, so that way the robot stops. Now this is the Turtle part of our code that tells the Raspberry Pi what to do when we press W, A, S, and D on our robot to control the robot. So these just turn on Turtle and open up a window here, which we'll see when we run the code. And all of these are the things that we need to tell Turtle to listen for when we're using our code. The Turtle on-screen screen on key press, move forward, W, basically means that when we press the W key on our keyboard, it's going to do the function move forward, which we've defined up here, and is going to move our robot forward. That's the same for the rest of these three. And then the on key release means that whenever we release W, A, S, W, S, A, or D, the robot will do the stop function, which stops all of the motors from moving. And this just tells Turtle to keep looping and not stop. Now this is our PiCamera code. So this is just going to set some tell the code to debug and print it into our shell, which we will see later. And this turns on our web server Flask. So now this code is what runs our camera. So this basically tells us that PiCamera tells the computer that camera equals PiCamera 2. So whenever we say camera, we mean to use PiCamera 2, which is the library. So this is configuring the camera, setting the resolution, the RGB format, whatever. If you want your camera to be higher resolution or lower resolution, change these numbers. And this just tells us which to use this line to configure our camera, and this starts the camera. Now all of this code here is just code to get the camera to run properly. You don't really need to understand it, you can just kind of copy it in, it should be good. And then this is for our Flask server, which is what's actually going to stream the video locally on a web server. So this again defines a function of video feed. You don't really need to know like what exactly this code does, it just starts a video feed. here too. This part basically means that at the end of our URL, we're going to have to write /video_feed to access our video feed. And this part basically just starts our turtle to make the robot move around. And this part starts our Flask on port 5000 with the IP of our Raspberry Pi. So now that we went through that code, we can go up here and hit run. Okay, after your code has run, you will see a window like this. So this is what you're going to use to drive around your robot. You can resize it if you want, if it's too big, too small, whatever. You can left click it and use W, A, S, D to drive your robot. W goes forward, D right, A left, S to drive backwards. So you need to make sure that this window is selected to drive your robot. Like if that window is not selected, say Thony is selected, it's just gonna type in and you don't want that. So you need to have this selected to drive around your robot. And now to access our camera feed, we're gonna head over to our web browser. There are actually a few ways you could do this. So you could just left click here and this will open up the web browser in your Raspberry Pi, but we don't recommend doing this because there's a lot of latency. If you want to have less latency, which is what we recommend doing, you're going to open your browser, go in the URL bar and type your Raspberry Pi's IP address, which is what we used to VNC into it earlier. We're going to specify port 5000, and then we're going to type /video_feed to access our video feed, and we're going to hit enter. And now we can see the video feed from our robot. If you do this and you can't see the video feed, then make sure that you haven't already accessed the video feed through the Raspberry Pi, because if you click the link that showed up here and opened in your Raspberry Pi, it will not open in your browser. You need to stop the code and run it again for that to work. Once you have done this, you can start driving around your robot.
In conclusion, at the end, you'll have a functioning robot built with the Raspberry Pi from scratch, which you could use to move around, play in your house, and with your friends.
For future projects, you can use this. You can add an ultrasonic sensor in the front for obstacle avoidance. You can add sensors at the bottom to follow a line, and other coolest things that we will cover in future videos. So that's why it's important that you turn on your notification bell and hit that subscribe button. See you later, YouTube.